We are taught to understand our planet by looking at objects like this classroom globe, focusing heavily on familiar landmasses. We operate under a terrestrial bias, assuming the most significant parts of Earth are found on solid ground. For centuries, cartographers meticulously mapped the borders of continents and the interiors of new lands, leaving the oceans largely featureless and blank. When we think of massive geological valleys, we picture the Grand Canyon, a mile-deep trench carved into the rock. And when we consider planetary extremes of elevation, we look to the summit of Mount Everest, soaring almost 30,000 feet into the sky. But measuring the planet's extremes using only the land ignores 71% of Earth's total surface area. The maps we study are essentially a cropped image, hiding the actual extremes of the planet beneath millions of cubic miles of salt water. To see the actual surface of the Earth, you have to run a thought experiment. Imagine pulling a planetary drain plug and watching the oceans rush away to reveal the scarred bedrock beneath. What emerges from that water is the true primary mountain range of the planet, the mid-ocean ridge. This continuous, elevated seam of rock wraps entirely around the globe, like the stitching on a baseball. To understand that scale, consider the longest mountain range on land, the Andes. The mid-ocean ridge stretches 40,000 miles, dwarfing the Andes tenfold. This ridge is an active tectonic seam, where magma rises from the mantle, cools, and pushes outward to generate brand new crust for the planet. The largest geological structure on Earth is an active engine submerged in darkness, driving the tectonic evolution of the world. As that new crust pushes outward, the old crust eventually collides with continental plates and plunges back down into the mantle at subduction zones. These create the lowest points on the planet. The absolute deepest of these is the Mariana Trench in the western Pacific. If you were to pluck Mount Everest from the Himalayas and drop it directly into the bottom of the Mariana Trench, the highest peak on land would still be buried under a mile of water. Our terrestrial extremes are physically insignificant when swallowed by the true voids of the ocean floor. Despite their dominating size, these massive geographical features remain almost completely shrouded in mystery. Absolute darkness and crushing hydrostatic pressure prevent direct exploration, leaving the majority of the planetary floor unobserved. Today, humanity possesses better topographical maps of the surface of Mars than our own ocean floor. Scientists are forced to map these deep regions using slow, remote sonar, bouncing sound waves off the bottom from ships on the surface. We look to the stars for alien landscapes while remaining locked out of the majority of our own planet. When we conceptually refill the oceans with water, the map quickly returns to the standard, familiar blue globe. The blue parts of the map serve as a thin, opaque cover for massive geography, concealing the rugged landscape beneath. The familiar continents are merely high-altitude plateaus poking out above the waterline. What humanity calls the world is merely the dry crust we happen to step on. The true extreme engine of Earth operates entirely in the hidden darkness below, reducing our terrestrial reality to a surface illusion.